Assalamu alaikum. Hello and welcome to this webinar on fluid sealing in power generation. I am Syed Hamza Ahmed, a mechanical applications engineer at Omega Fluid Controls. This is the third webinar in the informative series of webinars on fluid sealing, fluid controls, and industrial applications hosted by our engineering team at Omega Fluid Controls. This webinar in the series will be an introduction to Omega Fluid Controls and highlight Omega's comprehensive range of products and services. This webinar showcases how Omega's products serve power plants, electricity production, and energy industry, ensuring quality, safety, longevity, minimal maintenance, and compliance with local standards. In this presentation, we'll go through power generation systems and our solutions for those, as well as principals and partners, along with Omega's assurance program. Omega Metal Industries is a 3-decade-old company, and in 2022, as part of diversification efforts and its vision, Omega began its oil and gas equipment manufacturing division for the manufacturing of API-specified products. And the following year, in 2023, Omega Metal Industries forayed into manufacturing of fluid sealing and pipeline products with the establishment of Omega Fluid Controls. Being the first manufacturer of metal expansion joints in Saudi Arabia, we are at the forefront of offering pipeline solutions to all industries in the region. Going ahead, I will dive into today's topic, which is power generation systems. The power generation systems we come across in the region can be broadly divided into 3 types based on the type of energy production cycles. These types are steam turbine power generation, which is generally known as thermal power plants. Another one is combined cycle power plants, known as CCPP. And the third is the cogeneration, which is the combined heat and power cycle. So starting off with the first one, the steam turbine power generation. So this type of a cycle, which is an idealized Rankine cycle, generates electricity by converting heat energy from a boiler into mechanical energy. Water is pumped to high pressures, heated to produce high pressure steam, which then expands through a turbine to spin a rotor. This rotor is connected to a generator producing electricity. The steam is then condensed back into water in a condenser, creating a closed loop system that returns the water to the pump, completing the cycle. Here, the major equipment that we see are boilers, steam turbines, condensers. The key stages of the cycle starts with pumping. The water is pumped to a high pressure, then boiling. This high pressure water then enters a boiler where it is heated to become high pressure steam. Then this steam is superheated beyond its boiling point to a high temperature. Then the expansion occurs where this high energy, high pressure steam expands through a multi-stage turbine, where its thermal pressure energy is converted into rotational mechanical energy. After this steam has spent its energy, it is expanded in a condenser. This expanded steam exits, the expanded steam is introduced to a condenser, which then exits from the turbine and enters a condenser where it is cooled and condensed back into liquid water. Then this condensed water, the feed water, is then returned to the pump, completing the cycle and allowing it to begin again. So the conditions that we see in such a power generation system, namely in the equipment boiler, we see the temperatures going up to 500 to 620 degrees Celsius. This is high pressure and high pressure steam. Pressures that we see here are 120 to 250 bars, where the media is water. Steam turbines. Here we see temperatures of 540 degrees to 600 degrees Celsius, the pressures being 160 to 250 bar. Mind that this steam here is superheated steam that is being introduced to the turbines. And then we see a temperature of 25 to 40 degrees Celsius for the condensers, and pressures of 0.05 bar to 0.2 bar. Here the media is vapor and cooling seawater. Now, if we take a look at the kind of products that go into such an application, we see for these kind of operating conditions, we have gaskets like NovaFit SSTC, we have Nova Press 850, we have Omega joints, and valves for the boilers itself. Now talking about the steam turbines. Here we have omega joints that are the expansion joints, which are very vital for the steam turbines so as to compensate for the vibrations in the system, as well as for the pressure spikes that occur throughout the systems. The expansion joints are very important here. Also, we have NovaFit SSTC, which is the graphite-based gasket, which is very vital for sealing the entire media inside this closed loop system. We have the condensers, where the temperature is nominal and the pressures can be from nominal pressures as well as vacuum pressures. So here we see a very simple application of gaskets, which can be the Nova 1 blue gaskets, which can be used throughout this plant, as well as there are omega joints and valves that come into play in this kind of an equipment. Moving on to the next one, here we have the combined cycle power plant. A combined cycle power plant integrates gas and steam turbines to generate electricity with high efficiency. The main components are a gas turbine, a heat recovery steam generator, and then a steam turbine. These work together with the gas turbine exhaust heating water in the heat recovery steam generator to produce steam, which then powers the steam turbine. Here, the components that we see are the gas turbine. I'll go through the equipments here. The gas turbine is the primary component. Using natural gas or any other fuel, usually we see gases as well as mineral oils here to produce hot or high pressure exhaust gases. These gases spin a turbine, which is connected to a generator to produce electricity. Now, a heat recovery steam generator captures the waste heat from the gas turbine's exhaust. This heat is used to generate steam from water, increasing the overall efficiency of the plant. So when this steam is introduced to the turbine, we need a steam turbine. The steam turbine the steam produced in the heat recovery steam generators is directed to a steam turbine. This turbine, like the gas turbine, is connected to a generator, producing additional electricity. We have other control and electrical systems to go along with this, but main components are the turbine, gas turbine, the steam turbine, and the heat recovery steam generators. So this type of combined cycle power plant is a highly efficient type of power plant. It uses both the gas turbines and steam turbines. The recovery heat allows for more electricity to be generated from the same amount of fuel compared to single cycle power plants. Hence, it achieves higher overall efficiency by utilizing the heat from the gas turbine's exhaust as well as the heat that is remaining in the steam. The equipments that we see here are the gas turbines, the heat recovery steam generators, the steam turbines, the feed water pumps to circulate the media all throughout the system, and cooling systems that go along with it. So the added advantage in this kind of a cycle here is that the power station provides the desalination facility with steam to heat the seawater distillers while reducing its own cooling demands, which we have seen here in the region. So let's go through the equipment and the operating conditions. For gas turbines, we see really high temperatures, reaching up to 1200 to 1500 degrees Celsius, where the spent fuel in the form of gas impinges on the gas turbines. Here, the pressures are as high as 20 to 30 bars of pressure. The media is fuel exhaust, and the gaskets, metallic gaskets, usually are utilized in these kind of turbines. Here again, omega joints, that is expansion joint, plays a very important role in compensating for the high vibrations as well as pressure spikes occurring in this equipment. We require high pressure valves and associated components that go into valves as well. We provide these gaskets, we provide expansion joints as well as high pressure valves that are suited for high temperature, high pressure applications in gas turbines. Now talk about the heat recovery steam generators. So heat recovery steam generators usually see temperatures of 550 degrees Celsius to 600 degrees Celsius and pressures from 120 bar to 150 bars. Here again, the graphite gaskets play an important role in sealing the fluid, sealing the steam and the fluid within the system. Omega joints play an important role here, as we'll see in the next few slides. Steam turbines. Again, we see a temperature of 540 degrees to 600 degrees Celsius and pressures of 120 to 250 bars. Similar to the gas turbines, here we use metallic gaskets as well as omega joints for the expansion joint and valves. Feed water pumps see temperatures of 120 degrees Celsius to 180 degrees Celsius or even lower than that. Pressures can be 160 to 220 bars. Here, for expansion joints are used so that we can accommodate for the pressure spikes due to opening and closing of valves at the discharge end of the pumps, as well as other piping systems. The gaskets here are best suited gaskets here are Novatec Premium XP as well as Nova Press 850, and for lower temperatures we can have EPDM or rubber gaskets as well. For cooling systems, we see nominal temperatures as well as nominal pressures. Here, the all-in-one gaskets that we have, the Nova 1 Blue, can be utilized to great extent. Now we talk about the third part, that is the cogeneration. This type of a cycle, also known as combined heat and power cycle, is the simultaneous production of electricity and useful thermal energy, either for heat or for cooling, from a single fuel source. Instead of wasting the heat byproduct of electricity generation, combined heat and power systems capture and utilize this heat for heating or cooling processes, significantly increasing overall efficiency and reducing energy cost and emissions. So combined heat and power systems achieve significantly higher efficiencies. This improved efficiency leads to reduced energy costs, lower carbon emissions, and increased energy systems. And this kind of a cycle is increasingly being used in many of the power plants. So basically, this kind of a power cycle requires boilers and steam turbines. It requires heat exchangers and cooling towers, as is common in all other power plants. So combined heat and power cycle works in the following way. The fuel input, a primary fuel source like natural gas, is used to power an engine or turbine, which is then connected to the engine or turbine or electricity generators. Then this spent energy from the media is reutilized with the help of heat recovery. The heat that is a byproduct of this process from exhaust gases and engine cooling is reutilized. Thermal energy is recovered. This recovered thermal energy is used to provide steam, hot water, or utilized to produce chilled water for cooling and in other industrial processes. So the equipment that we see here are boilers and steam turbines, which see a temperature of 400 to 600 degrees. Pressures are 60 to 100 bars, and the media here again remains water. The gasket that can be utilized here is Novopress 850, or in case of metallic gaskets, they are also seen in the system. For temperatures that are lower, we can use EPDM and rubber gaskets to seal the fluids inside. Omega joints again play a very important role in this boiler and steam turbine system, where the pressure spikes are very detrimental to the piping system, and as well as we utilize valves where to control the media, to control the inlet and of the steam to the turbines as such. Heat exchangers see a temperature of 80 to 150 degrees, the pressure being 1 to 15 bars. Here again, Nova 1 Blue is a one-size-fits-all kind of a gasket which can be utilized in multiple applications without much, without the hassle of interchanging different gaskets for different particular applications. And for graphite use gaskets, we have the NovaFit SSTC gaskets, which go into heat exchangers as well as normal applications as well. We have omega joints as well as valves that are utilized for this purpose. The cooling towers see a temperature of 30 degrees to 50 degrees based on the inlet and outlet of the system. The pressures here are 1 bar to 3 bars, which is a very nominal application. Again, the Nova 1 Blue, which is the best suited for these kind of applications, is the best solution that you have for cooling towers. So now we talk about the heat recovery steam generators that we mainly see in power plants in on multiple cycles that we have studied. The heat recovery steam generators is a system that captures hot exhaust gases from sources like gas turbines and converts their thermal energy into useful steam. This steam can then be used to drive a steam turbine for electricity generation or for various industrial processes in a cogeneration system. Heat recovery steam generators significantly increase the overall energy efficiency and reduce the carbon footprint of power generation and industrial facilities. These consist of four major components, that is the economizer, the evaporator, the superheater, and water preheater. Since the evaporators are enclosed in structures that require isolation as well as flexibility, there's huge applications for expansion joints, usually rectangular expansion joints in between the different segments of the heat recovery steam generators. Here, the expansion joint that is utilized is usually the fabric type expansion joints. However, we do see other kinds of expansion joints as well. So these large size expansion joints are essential to keep the fluid enclosed in the system, whereas it needs to act as it needs to seal the media inside, as well as for the effective operation of these heat recovery steam generators. Even a minute leak in these kind of expansion joints, a minute leak of the fluid outside to the outside of the system can lead to losses that defeats the purpose of a heat recovery steam generator. So these expansion joints are very vital, and a good quality as well as a good functioning expansion joint is very vital for these applications. Talking about omega joints, we pride ourselves at being the first manufacturer in Saudi Arabia for metallic expansion joints, and our facility is located in the Dammam Second Industrial City, that is the Modon. These metallic expansion joints are made entirely local, and the raw material for the rubber and the fabric expansion joints may come from outside. We have the capacity to manufacture metallic expansion bellow elements ranging from 12 inches to 2 meters. When we're talking about this the bellow type expansion joints, which are circular in diameter, and other sizes can be accommodated to even larger ones if you're talking about rectangular expansion joints or fabric expansion joints. So 12 inches to 2 meters is for the metallic expansion joint that is in the form of a circular bellow. We have, as I mentioned earlier, expansion joints are often installed near boilers, heat exchangers, pumps, turbines, condensers, engines, and in long pipe systems or pipe ducts. So these different applications require different types of expansion joints, and we are capable and we perform manufacturing of specialized expansion joints. We also have rubber expansion joints which is more suited for simple media such as water. So we have rubber expansion joints in different configurations and pipe systems. The material of construction is designed based on the application requirements. Omega also has a wide range of products, starting from locally produced and Saudi-made expansion joints, which can be made in these metal, rubber, and fabric, all the way to gaskets, compression packings, and insulations as well as valves, which are very important. So for these, we to provide these the comprehensive pipeline solutions, we are partnered with esteemed companies like Frenzilit and Vishwakarma to provide fluid control products like gasket seals as well as valves, dismantling joints, and other products. Frenzilit is a Germany-based global company that produces gasket material and other products with precision and consistent quality. Vishwakarma Engineering is a manufacturer of valves. We have partnered with Vishwakarma Engineering to provide valves in Saudi Arabia. With the gaskets going into different type of applications, whether it be water purification, whether it be power generation or petrochemical industry, providing reliable solutions is very important. As the first soft gasket for Industry 4.0, Frenzilit has innovative gasket code technology, which is standard throughout its product line, which ensures reliable and unique identification of material, including the production period from even the smallest gasket dimensions. So here we have a range of Frenzilit gasket products, starting from 200 degrees Celsius applications to 1000 degrees Celsius application. These have the required compliance certifications, whether it be for food and drinking water, whether it be the TA Luft or the leakage uh, tests that are usually required by most plants. Also, we have 5 safe gaskets as well, and the gaskets suited for cleaning in process applications. These kind of certifications are present for all the different models that we see. The other products that we have are thermal and acoustic insulation materials. Apart from fabric expansion joints that are used in exhaust manifolds or in different HVAC systems, we have thermal and acoustic insulation materials and heat shields and other innovative composite materials for different applications. We have partnered with Vishwakarma Engineering to manufacture valves in Kingdom as the first phase and are in process of importing technology to ensure the right valve solutions are delivered to the end users. Valves in water systems are crucial for controlling flow, pressure, and isolating sections for maintenance or emergencies. These valves, if when the pressures are high and we see high temperatures, these high temperature and high pressure valves are uh, very vital to the functioning of a power generation system. The key types of valves that we do see here are the gate valves, the butterfly valves for flow regulation and isolation. We see ball valves for reliable shut-off of the system, and check valves for preventing backflow. Now we talk about the Omega Assurance Program. As per Omega Assurance Program, our quality assurance and quality check team ensures that all our metal expansion joints and valves are being tested both by non-destructive testing as well as destructive testing methods and other testing procedures like hydro testing, helium leak detection test, radio testing, radiography testing, cycle test, and burst test. These tests are performed based on the requirements as mentioned by the client, and we do all the types of tests that are requested. Here are some of the tests that are performed: the leak test, the burst test, the life cycle test, the dye penetrant test, to assure that the material that goes out of our manufacturing unit is tested to the best standards. Apart from as part of our services, Omega Fluid Control provides complete site support for the end user, where our subject matter experts conduct the site surveys to assist during the planned as well as emergency maintenance activities. During our preliminary visit to the customer sites, we take the measurement of the existing joints, we perform the failure analysis and share the reports with the end users and recommended a best suited product based on the application details. And as part of our commissioning services, we provide end-to-end installation support for the expansion joints and other products as well. At Omega, with our in-house research and development engineering team, we provide the best possible high quality and cost-effective solutions to our client. And here are a few end users and operators featured for reference where Omega has provided its products and services. We are constantly expanding our solution base and improving our customer service, and we would like to design solutions to your industrial needs. Thank you for joining in. If you have any questions, feel free to send it to our contact details. I am Sayed Hamza, the applications engineer. You can send your mail to me on engineering@omegamed.com, or for sales inquiries, you can forward it to the sales@omegafcs.com, where you will be responded to as quick as possible by our business development manager or the regional sales director or any of our team members. If you need any on-site or off-site support, we are here for you. You can follow us on LinkedIn for more updates. Keep tuned in for the next webinar, which will be released, with the information about which will be released on LinkedIn in a short while. Thank you and have a nice day.